All right, so here we go. We're talking about section 5.5, integration methods. So Brian and Noah were in my Calc 1 class before, so I'm just going through my checklist, right? Just so you know. And then we're going to hopefully add integration by parts today, which is 5.6. 5.7 is trigs, two types of trigs, and also partial fractions. And then that's going to complete our list, right? So integration methods. The first one is that you just recognize it, right? So you know the derivative, right? So you recognize the derivative, right? So meaning, oh, I see f prime, right? And I know that turns into f of x plus c, right? That constant of integration. So I recognize what function I took the derivative of to get f prime, right? So for example, cos of x dx. What did I take the derivative of to get cos of x? Sin x. Right? Or 1 over 2 square roots of x dx. Right? What did I take the derivative of to get that function? Square root of x. So all of my methods will eventually turn into this. I'll eventually recognize what I have, and I'll just be able to do the antiderivative at that time, the integral. Second level, and I always do these every semester, and I never write them in the same order exactly, but the idea is, as you're given a problem to integrate, you want to say, oh, do I recognize? Go down the list. I'm writing the list in order because the easiest methods will be first, right? And if everything fails, then I'm going to my sequences and series in chapter 8. If everything fails on my list, it'll lead me to chapter 8, okay? So, like, for example, the integral of e to the x squared dx cannot be solved. Cannot be done until chapter 8. I could estimate it, right? I could estimate this. But I can't actually say this is the function that I took the derivative of. So second level, our second level here, and Noah, if I need to zoom, you tell me, okay? If anything's clear that I'm writing, it's not right. Just tell me. Well, I want to help. Second level is I think the power rule, right? So we know if we have the integral of x to the n, I get x to the n plus 1 all over n plus 1 plus c, right? I'm adding to the power, dividing by the new power, right? For example, right, if I have the integral of x dx, right? Well, I could think about what did I take the derivative of, or I could just recognize that I have x to some power, right? So I've got x to the 1. I'm going to add 1 and divide by the new power plus c. So x squared over 2 plus c. And remember, and this is really valuable to us, is what can I do to check myself? Well, I can go on Symbolab, right? No, well, you won't be able to do that on the test. You will have a computer in front of you, but I'll be watching, right? Someone's always watching. So, but what can I do to check this? Take the derivative. I can just take the derivative of all my answers and I'll know I have it right, right? And if you get it wrong on your test, then I'll say, did you check it? Right? Did you check it? There's no reason for you not to take a derivative of an integral to double check it. It's always going to be. Let me show you Symbolab real quick. There's a lot of these now, symbolab.com. And you're free to go to it right now with the computer in front of you. And you can see I've got a prime symbol here, right? So there's, here's my integration, right? This is partial derivatives. You'll do that in Calc 3. So there's all kinds of things here. Let me see what happens when I just pick this integral. So I want this one. I don't want the definite integral here. I'm not looking for an area. I'm looking for a function, right? So what did I have? Oops, sorry. Yeah. So I'm just typing in x dx. There is kind of a space there. The dx and the integral symbol are the operator. But I think if you don't type it, it will still give it to you. Right, and then here, I can just say go. And there's my answer, right? And then I can also show steps. Not that there's much there. You have to sign in to see the steps. So create an account and sign in or something like that. I used Wolfram Alpha when I was in grad school. Very, very powerful. Same thing. We used to give out the login version of it here, but we don't do it anymore. So, but their Symbolab is probably the best I found. Does anybody use anything else? Mathway, Photomath, there's so many of them, right? But we want to know we're right. That's the thing. We don't want to lie about it. We don't want to fake it. We want to know we can do problems and get to the answer, right? So you can't. So if you're having trouble getting to problems, don't waste your time doing more problems. Come see me after class, and we'll do something together, right? That's going to be the key. Is to work smart. Do as many problems as you can in the shortest amount of time as you can. If you're getting things wrong, try Symbolab. See if that helps. Try something else. Ask for help is really going to be the key. And we do have an embedded coach here working with us this semester, Dr. Early. I don't know if any of you know Dr. Early. He teaches on this campus. He went to Howard for math or engineering, and then he went to Caltech and finished, got his PhD in engineering. And then he came back and taught at Howard, ran the engineering department. Okay, I believe he's an electrical engineer. I forget. Caltech would make sense, electrical engineer, yeah. So he's going to, and I'll put all this on Blackboard. He's available online for help. So weekends even, evenings. So, take advantage of it, okay? Next, my third level here are just a couple of little tricks. And the tricks, and you'll see, I might not put them all there. I might come back later and say, oh, this is another trick. So like a big trick would be long division. Divide and conquer. And you'll see all of them as we go. I probably won't give you a demonstration of all of them right now. Multiply by 1. add 0. I might be missing something, but I'll do one real quick. Dividing with a long division. When I'm doing long division, I'm looking for polynomial over polynomial. And of course, I don't see any yet. I'll just make one up. So this is a long division. I'm looking for my numerator power to be equal to or greater than the denominator power, right? So something like x to the m over x to the n plus, right? And I want m greater than or equal to n for long division. It's possible you could do the answer, you could get the answer without doing long division, okay? But it will be different than the book. It'll still give you the same area, okay? But it won't be as elegant. We're always trying to write, as computer scientists, you know, you want to write as much as you can with the least number of strokes that you can, right? And that's what we're shooting for here when we do all this integration. We want our answer to be as concise as possible, right? So what do I get here? X squared plus 1 divided into x squared, right? Goes one time for sure, right? And then I get a remainder of minus 1. So this integral of x squared over 1 plus x squared dx. And you'll see me do long division or sometimes synthetic division. And if there's ever a time when you're like, wait a minute, right? You got to make sure you let me know. So what did I get out of this? I got 1 plus negative 1 over x squared plus 1. And you can see right there's my long division piece. And then, of course, I can split this into two integrals, right? So the first one, how did I get, right? This is the level 1 problem. How did I get a 1? What did I take a derivative of? X, yeah. And then the second one, anybody see it? Arctan of x. The inverse trigs is one of my list, one item on my list. Everyone okay here? Yeah, so like if I did 4 into 21, right? It goes in 5 times, and then I get a remainder of 1. But you remember we used to, so we would write 5 remainder 1 or 5 1/4, right? Yeah. Yeah, absolutely. This is that's 4th grade. We stopped doing that a long time ago, right? But it's okay. Yep. Let me do a multiply by 1 here, okay? So another example, and multiply by 1. Noah, are you okay? Yep. So 1 over square root of x dx. So I'm really at level 1 here, but I'm missing a 2, right? I'm missing the 2. I need 1 over 2 square roots of x to recognize that it's a square root of x problem, right? So what I do is I multiply by 1, I multiply by 2 on the outside and by 1/2 on the inside, right? So now I've just multiplied by 1, and I can do this with constants. I can do it with coefficients. I cannot do it with variables, right? So then I recognize I have 2 square roots of x plus c. So when I'm looking at the Shams, by the way, they're just giving me the formulas, right? 1 to 26 are the formulas I guess we're supposed to kind of have memorized to this point. I didn't, so in my class, I did not teach you 21 to 26, but I will. Those are going to be either trig substitutions or partial fractions. So wait for me on those. But then, so what I'm asking you to do this, tonight is start working on the solved problems, which is 1 through, and I think we can get probably up to, well, I'm going to try and go all the way up to 72 today. We will take a break. If you need a break, just go ahead and take one, okay? I guess I have to, let me just pause this real quick. So I'm going to start doing some U subs. I think there's about 4 or 5 different versions of U subs. And so, so the first one is, I see a function and its derivative. I see a function and its derivative and nothing else, okay? So I'm going to let u equal the function, and then du equals f prime of x dx. So this guy turns into u du. Do you remember doing this? Yeah? Yes? Yeah, good. So if I see a function and its derivative, this is my first choice for a u sub. And of course here, you can see this. You see, so this is called change of variable. Now, instead of x being my independent variable, u is my independent variable, and everything behaves like it did, right? And so I get u to the first plus 1 all over 1 plus 1 plus c, right? So again, you see, I did a u sub method, and it turned into method 1, right? Really quick. Or method 2, power rule, right? And you don't have to know the numbers, right? And like I said, sometimes I'll do them in a different order, but this is generally what I want to look for. If I can do them in the order, they're easiest as we go. So let's have you do one of these, right? So I'm claiming that this is my level 4 problem here. So, but what do we have to do first? I see a function 2x inside. But my outside function is sine. I don't see a cosine. So can I do something to sine 2x, right? Can I do something to sine 2x? That's 2 sine x cos x, right? Yes, you remember that from pre-cal? And now my 2's cancel. And now I'm finally there where I see my function and a derivative. So which one do you want to call the function? Yeah, sure. Sine x? Yeah. So if u is sine x, what's du? Derivative of sine is cosine. And so you see here I've got now the integral of u du. So that gives me u squared over 2 plus c, but u was sine, right? So I get sine squared x over 2, all over 2 plus c. How's my speed so far? Is it okay? Am I going too fast? We're okay? You're paying me, whether you're paying me directly out of your pocket or via the government or whatever, right? So you make sure you get your money's worth. You control me, okay? So u sub whole function. Next is u sub inside. Next is u sub downstairs. Then two more, okay? So here we go, next one. Say again? Yeah, go back. Just, you gotta, I can't hear really. You gotta yell at me. This one, the first one, I said it's a u sub is the whole function. Yeah. And again, it's not, you're not going to need the list. I doubt you would need the list on your formula sheet for the test. I would say you would need, if you practice, you won't need the list. You would need a process, right? So when I get to integration by parts, there's a process, an algorithm, how to do it step by step. That, I would say, you would need more. A particular process that you might have trouble with inside of my big list of try this first. Because you will get really good at seeing, oh, that's a u sub inside. As soon as you, and you'll see it here, as soon as you see my function, you'll see there's really a clear inside, right? So we're going to let u be the inside, and du is 2 dx. Do we agree with that? Good. Do I have a 2 dx? No. So I have to make that happen. That's my trick from before. I need a 1/2 and a 2 to cancel, right? But now you see I have a 2 dx, and that becomes du. Right? You with me there? So now I have 1/2 of the integral of e to the u du. Oh, but I recognize e to the x as a derivative, right? What did I take a derivative of to get e to the x? I took a derivative of e to the x. So I get 1/2 of e to the u plus c, and u is 2x. So it will be really, really clear that there's an inside. Where is the trickiest inside of my inverse trigs? So, but I have a whole section on inverse trigs, so I'll just wait for that. But it's hard to see. It's hard to see in this particular problem that there's an inside there. And you can see what it is, right? What do I actually have inside there? X squared, right? And then notice that u is x squared, and what's my derivative of the inside? 2x. So that's a hard one to see for the inside, but I'm going to put that into my inverse trig antiderivatives, okay? So of course this one is u is x squared, du is 2x dx, right? And now I have the integral of 1 over 1 plus u squared du. And of course, that's arctan, right? Say it again. Yeah, that's an x squared, yes. Yeah, I cannot write in that color anymore, if that's gonna do that to you every time. Purple easier to see? Yeah, yeah. So usually the inside is very, very obvious. And of course, what kind of derivatives are we talking about if we're talking about an inside? It might be a power rule, but not necessarily. It's another kind of blank rule. What rule? Chain rule. So since the chain rule happens all the time, this integration method of u being the inside will happen quite a bit. Okay? Good. So now u sub downstairs, method 6 here. And again, who cares about the numbers? So this is, I'm looking at the Shom's problems. So first of all, if I have this, what's my result? Right, this is level 1, right? If I see 1 over u, the integration of that, what did I take a derivative of? ln, right? And in this case, I need the absolute value. My Shom's doesn't put the absolute values on. The book does. Okay? So plus C, right? So this is from Shom's. Oops, I lost my page. Oh, yeah. 1 over 1 plus e to the x dx. Now, this is a tricky problem, okay? But clearly, there's no inside. If there's an inside, it's x, right? E to the x is my function piece there. So I need a complicated inside, right? Think about that for the chain rule. So this one actually is a downstairs u sub, but I have to first multiply by 1. It's hard to see this one, and there are going to be problems like that. Do you remember doing your trig identities? Prove the following trig identities. And there was always 1 or 2 that you get stuck on if you did them all, like I did. The same thing with integration. There's going to be 1 or 2 that you're going to get stuck on that you have to kind of remember that trick now. Maybe I need that trick. And this is, I'm multiplying by 1. It's very strange because I'm using a variable, right, over itself. But I'm inside the integration. If I'm inside the integration, I can do this. I can't do an e to the minus x inside and a 1 over e to the minus x outside. Can't do that because the integral itself is dependent upon the variable x. So what do I get upstairs here now? Right? And downstairs, what do I get? What happens when I multiply e to the minus x times e to the x? right? Well, now there's an inside, but the inside is negative x. So you can see it's not going to change much. But I'm going to let u be the whole downstairs. So what's du? What's that derivative? It's an e, right? Say again? Almost negative e to the negative x. Negative e to the negative x dx, right? I got to use that chain rule, right? If I have a complicated inside, I got to make sure I take the derivative of the outside, evaluate it at the inside, times the derivative of the inside. So it looks like my integral needs a negative on the outside and a negative on the inside. So now you notice my whole numerator is du. Make sure you're with me here. So now I have the opposite of the ln of the absolute value of u plus c. And there's my final answer. Typically, if the function piece is using is a negative, I'll put the c out front, the constant of integration out front. So that's a tricky one, but we'll do another one like that. And not so tricky though. This is number 21 in Sean's. You will notice that that thing could be factored downstairs. And when we do partial fractions, that's a process that we're going to be looking for. Can I factor the denominator? On this one, because I'm only up to my list of up to u sub downstairs, that's really my only choice here, right? And then du is 2x dx, yeah? So I need a 1/2 and I need a 2, right? Is everybody comfortable with that process? Everyone comfortable? Daniel, yes? You're comfortable there? Baruch, you're comfortable there? Yeah? Ryan? Yeah, so notice I need a 2x dx. I don't have it, I have an x dx. So if I multiply by 2, I can't just go into the bank and double my money, right? But if I say, hey, double my money and then cut it in half, that's fine, right? I still have the original. So now I have 1/2 of the integral of 1 over u du. So 1/2 of the ln of the absolute value of x squared minus 1 plus c. Do I need the absolute value there? Is x squared minus 1 ever negative? Is it ever negative? Look at it. Is it ever under the x-axis? Yes. So I need the absolute value. If you remember, if you were in my Calc 1 class, you would see me move that 1/2 in a lot as a square root, right? In this case, I still need that x squared minus 1 to stay in absolute value. All right, so we got a u sub with a function, u sub inside, u sub downstairs. Now a u sub, but there's leftover x's. So a u sub, but when I do my work, I have a leftover x term, or x squared term, or x cubed term, if I was going to be evil, x cubed. I think our textbook goes up to x squared. Not sure I have any of these here, but I'll get you some. So I'm claiming that I could do a u sub process, but then there could be leftover x terms, and if that happens, either this process will work or nothing will work. And then we're in chapter 8 again. Okay? So here it's a clear inside, right? And then du is what? Negative dx? We agree with that? Don't let me do that part if you're not comfortable with it. Daniel, Baruch, yes? Ryan, yes? I know they're comfortable with it because I tortured them all last semester with it. Am I right? Brian, no, you're comfortable here, right? So it looks like I need the negative again. Notice that those two negatives, one inside, one outside, just cancel, right? Because now in blue, I've got my du, right? You see that? Negative dx is du. And notice what I have. Look at what I have. Got a leftover x. I'm not saying every time you have a leftover x term or x squared term or etc. that this process will work. You have to let things happen. If it fails, it fails. Right? You know what I'm saying? If you go through this process and it doesn't work, and you'll know it doesn't work because it's going to get worse. It's going to get worse looking. It's going to get complicated. Okay? And then you're pretty much going, no, I don't think this is going the right way. You know, and then you'll go do it on Symbolab and you'll see something crazy as a result, right? So, but notice that u equals 3 minus x gives me x equals 3 minus u, right? And now this is looking a little bit better. I kind of can see that I have towers, right? So I'm trying to get it to somewhere where back on, easier on my list, right? We okay here? Yeah, okay. Yeah, nice. So then I'm just splitting into two, right? Two problems. This is kind of where I'm saying I'm hoping you're ahead of me, right? But if I'm doing something that you don't agree with, you got to let me know, or you're just confused by it. When did we take Calc 1? Daniel, when did you take Calc 1? Yeah. Last fall. Wow. Baruch. Spring. Nice. Noah, spring. Brian, spring. Ryan, spring. So I'm worried, but you practice, right? You practice this stuff. Make sure you get it all back in your head. From Calc 1, we needed to have chapter 3 memorized and chapter 5 memorized. Right? So 3 is all the derivatives. Right? What's that? Yeah. Yeah. It's a hard class too. Um, it's just a lot. Hopefully, I'm gonna just take it easy on you all, but you got to do the work. You can't, right? Let's keep going here. 3 halves and 1 is what, 5 halves? Everybody okay here? My next step is going to be where I confuse you or lose you. But everybody okay up to here? Say again. I can't hear you at all. Yeah, yeah. I'm getting a LCD because I'm going to factor. So I'm going to factor out a 2/5. Oh, I'm sorry. A 2/5 u to the 3 halves. And now I'm finally ready for u. I think it's 3 minus x. And of course, we've all experienced that the algebra in Calc 1 is hideous, right? So, so you're gonna do your best to look at the answer in the book. If it's different, maybe you made a mistake. You try it over, you get the same answer. Then you know I just got to do some algebra to get it to be the answer in the book. Let's see what Simulab says on this one. So that they didn't factor it at the end. And if I wanted you to factor it, I'll put that in the instructions, right? Make sure your final answer is nicely factored, or something like that. But you definitely see my answer, right? You see my answer in that right before I put the LCD in, right? So I like to kind of talk about definite integrals at this point before I do my inverse trigs. Because I kind of have a u sub in here as well. So let me just do a real simple one. Let's say the integral from 1 to 2 of x square roots of 1 minus x squared dx. Eventually, we're going to see this as a trig integral. So, trig integrals, I'm looking for a right triangle, right? So if this was A and B and this is C, I could have what? Square root of a squared plus b squared. So I could have a hypotenuse, or I could have a leg, square root of c squared minus b squared. And so you can kind of see that I have a 1 squared minus x squared in my problem, my original problem here. That's hinting at a trig substitution. It's not a method we learned yet. We're learning it tomorrow, okay? But because I'm following my list, u sub inside happens first, right? On my list, u inside happens first before I get to trig substitution, which is number 15 on my list. And so du here is what? Negative 2x dx. So it looks like I need a negative 1/2 and a negative 2. So I've got a negative 1/2 times the integral of x equals 1 to x equals 2 of square root of u du. And so you can see where my u sub is going to happen here is I don't want x's, right? So what happens to u when x is 1? What happens to u when x is 1? u is in a box, right? U is 1 minus x squared, right? So what is u when x is 1? 0, right? And what is u when x is 2? Again, I'm plugging into here, right? -3, right? Of course, I just gave you a horrible problem to do that can't be done, but sorry. So forget I did it. But the idea is when I'm doing a definite integral, if my original bounds are in x, right, I've got to convert them to u if I want, or I can come back to the x world. So let me save face on that and do another one. Of course, I don't have any definite integrals in this packet, but in the book we do. So 45 there, right? Oops, sorry. So the integral from 0 to 1 of x squared times 1 plus 2x cubed all to the fifth. Right? 1 plus 2x cubed raised to the fifth. So definite integral. We want the area under the curve, right? There's a clear inside. Yes, you with me? No, are you okay there? You can see it? So u is 1 plus 2x cubed. Du is 6x squared dx. I almost have it, right? There's my 6x squared dx. So you see there's the issue. But if I take my x values and put them in, I can find my u values, right? So when x is 0, u is 1. Do you agree? And when x is 1, u is 3. Do you agree with that? I'm putting them right into here, right? My bounds were originally x equals 0 to x equals 1, but now I've converted everything to u by u sub. I want to make sure I convert my the bounds of my integral into u values. Three to the fifth. What the hell is 3 to the fifth? $243. Nice. So we have just our inverse trig methods. Then we'll take a break, and then we'll do some brand new stuff, okay? So almost there. There's so much material that I tend to simplify the amount of inverse trig or trig functions we use. So for the inverse trigs, I use arctan and arcsine only, okay? When you get to diffie-q's, you'll need the others as well. But if you get there, you can handle it, okay? So I tend to restrict myself to inverse tangent and inverse sine. So let's just review those real quick. If I say y equals the arctan of u, I remember that y prime is u prime over 1 plus u squared. And then y equals the arcsine of u. I got y prime is u prime over square root of 1 minus u squared. So those were our derivatives from chapter 3. Well, if you took Calc 1 with our book here, it's chapter 3, but when we did derivatives, we came up with these so that we want to be able to reverse it, right? Right, so we want to be able to say that u prime over 1 plus u squared du is arctan of u plus c, right? Kind of idea, right? So in this one area, I tend to think of there being 3 or 4 level problems, okay? So let's just look at them all with the arctan for now. Right, it's really level 1 again. If I just saw 1 over 1 plus x squared dx, right? Level 2, I'm just going to see something that doesn't look right. I'm going to see something that doesn't quite look right to what I want, right? And what is it that I don't like here? The 4. So what I'm going to do is I'm going to divide everything by 4. So that 1/4 that's upstairs is now out front. And I have 1 over 1 plus x squared over 4. And I'm kind of saying, well, can I make that x squared over 4 something squared? Right? You with me? Can I make that x squared over 4 something squared? And I can. It's x over 2 quantity squared. Remember, I want 1 over 1 plus u squared, right? So now I have to do a u sub. And this is where I said the u is inside is not that clear, but now it should be a little bit clearer that u is x over 2 and du is 1/2 dx. And you see I have a 1/2 dx, right? In blue here, 1/2 dx. That's du. So I have 1/2 of the arctan of u, which is x over 2, all plus c. Right? So we could just have a direct inverse trig. We could have an inverse trig that needs to be algebraically manipulated to get it to look like 1 over 1 plus u squared. Next level is I have to complete the square. So I'm assuming most of your teachers in Calc 1 didn't torture you with this. I did torture my students with it, so it's kind of why I'm going there right now, but this is number 65 in Sean's. They used y instead of x, doesn't matter. But I go through my list, right? First thing that might show up on my list is a u sub downstairs. But if I u sub downstairs, I need a 2x plus 10 for my dx, and I don't have it, and I can't make it happen. So I keep going down my list, and I think it's got to be an arctan, or Robert lost his mind and gave me a problem I can't do, right? So this one is an arctan. And so what I want to do is complete the square here. And I get half of this x coefficient, which is 5, square it, which is 25, and add it on the inside and subtract it on the outside. So the piece in the parens becomes this perfect square, and then I have that left over plus 5. Well, I almost have a 1 over 1 plus u squared, right? But I don't like that 5 that's outside, so I do that same trick as before. Divide everything by 5. Make sure you're with me here. Okay? So now I have a u sub, right? And u is x plus 5 over rad 5. And du is 1 over rad 5 dx. And I see that I have a 1 over rad 5 here. So this piece in blue is my du. Oops, forgot my square. Right? And that highlight in green is u. One more level. How are we doing? So there's a bunch of these to practice, right? I think it's number in Shams. It like starts around 50, oh no, starts around 52, yeah. Up to 72. Don't do past 72, okay? One more level. And then we'll take a break, okay? There really is a level 5, but I won't go there, I promise. Number 71 would be a level 5, where you have a leading coefficient of the x squared term that's not 1. But I'm not going to do that. I can't do everything, right? I can't do everything. It's kind of unfair to you, right? I'm trying to restrict it to 100 years of math instead of 2,000 years of math. Well, level 4 is going to involve me again completing the square, but this is number 68, but one of my earlier processes will cut off that I go right to complete the square. So this is 68 in Shams. So I clearly see there's a downstairs, right? So u is x squared minus 4x plus 8. And du is 2x minus 4 dx. Notice I'm grouping that in parens because I want to make sure I see that factor, right, of my differentials. Well, I need a 2x. Can I get a 2x? Can I get a 2x? Yes. I can multiply everything upstairs by 2. So now look at what I have. I have 1/2 of the integral of 2x plus 2 over x squared minus 4x plus 8. But I don't want a 2x plus 2. I want a 2x minus 4. So I'm going to subtract 6 and add 6. So I multiplied by 1. I added 0. So look at what I have. I have 1/2 of the integral of 2x minus 4 plus 6 all over x squared minus 4x plus 8 dx. Everybody okay with me? Now I'm going to divide and conquer. I'm going to call the first one hashtag and the second one star. Or asterisk, whatever. Because I don't want to keep writing them all over and over. I'm going to work on one and then the other and then put them together, right? Well, this one I already know. This is u. This is du, right? So I'm done with that one. 1/2 of the ln of the absolute value of x squared minus 4x plus 8. And it turns out that x squared minus 4x plus 8 is a parabola above the x-axis. So I can really write this as the ln of the square root of x squared minus 4x plus 8. You with me there? Like something on my test I would do, right, is I'd go to Desmos. And I'd graph that y equals x squared minus 4x plus 8, right? And I could see that that's never negative. So I don't need the absolute value, and then the 1/2 power comes in as a square root. But working on star, I get 3 times the integral of 1 over, and I want 1 plus u squared du. That's what I want, right? Again, I'm at the end of my list here, right? So the only thing left for me to do is to see if I can complete the square. Right, so I've grouped those first two terms together, make sure my x squared coefficient is 1, find the x coefficient of -4, get half of it, -2, square it, get a 4, and make sure I cancel it on the outside. So it's really starting to look like 1 over 1 plus u squared, right? I don't like the 4, right? Oops, don't use the green. So divide everything by 4. And I'm almost there. I've got one more u sub to do. Anybody overwhelmed? Anybody overwhelmed? No, we're okay? Yeah. A lot of steps to brushing your teeth. Right? It gets easy as we practice. So I have a u of x minus 2 all over 2, and so a du of 1/2 dx. I have that. Notice I have 3/4 dx. So I certainly have 3/2 times a 1/2. And then those two answers plus C is my final answer.